Now let's move to another random variable, which is normal distribution or normal random variable. Sometimes we also call it Gaussian distribution. Okay. See, the distributions, if you have noticed, and you should be convinced till now that whatever we have seen till now, maybe Bernoulli, binomial, or whatever we have seen, are basically based on some general phenomena, which means that they occur too often in the practice. Like if you ask about the Bernoulli, then if you're tossing maybe if you are having n trials, then sorry, if you ask me about the binomial, not the Bernoulli, in case of binomial, if you are having n tries, then how many success you are getting? That is modeled by the binomial distribution. Similarly, uniform is also, like in case of discrete, uniform is very general phenomena, like head and tail uniform, dice rolling uniform, like that. The uniform is general phenomena. Here also uniform is general phenomena, right? So uniform is also general phenomena, and whatever we have seen is actually general phenomena. Similarly, this normal distribution is also very general phenomena. And in fact, it is extremely general. I mean, it is very, very natural phenomena, which means the PDF of normal distribution is given like this, which says that if any random variable is following this kind of PDF, then we call it a normally distributed. Okay, normally मतलब ये तो expected ही था, मतलब normal मतलब हाँ, life is normal like that. Okay, मतलब बहुत काफी normal चीज है, ये इतनी normal है कि we are calling it a normal distribution. Okay, so I hope you are getting. Now let's just see that how to calculate. I mean, what does this mean for the normal distribution? Let me also tell you more. So basically, what do I mean by that? For any random variable, let's take some example. Maybe let's say that you are in a class, and then there are many students in the class. So generally what happens that most of the people lie in between. Matlab most of the people are average, right? I mean, there are some people which are below average. There are some people which are above average, but most of the people are average only, right? So this is actually very normal to have these kind of distributions in a class. If you have some test, then generally the marks of the test follow the normal distribution only. I mean, if the marks of the test are, let's suppose, from 0 to 10, then most of the people will lie in this interval. Let's suppose this is from 3 to maybe 8 or something like this. ठीक है, वो फर्क नहीं पड़ता. But most of the people marks between 3 to 8. बहुत ही कम लोग होते हैं जिनके 3 से कम होते हैं, कम लोग होते हैं जिनके 8 से ज्यादा होते हैं. So basically, it is very normal phenomena, extremely normal actually. And this is one of the most important with respect to machine learning, which means in case of practical applications, without this distribution, like machine learning applications cannot even exist. I can go to that extent, which means most of the data distribution that we use in machine learning we say that it is following a normal distribution. Okay, I mean, most of the things in a general life follows a normal distribution. You take anything. Maybe if I just take one another example, let's suppose if I talk about the height of the people, then let's suppose the height of the people are varying from, let's suppose 4 foot 8 inch or something like this. Let's suppose it is maybe anything. Okay, maybe let's suppose 4 foot 8 inch and 2 maybe 6 foot 10 inch. Okay, maybe 6 foot 5 inch, something like that, right? So height of the people is also in general, like most of the people height is in this region only, right? I mean, most of the people are common. Okay, most of the data is a common. I mean, most of the mass is always together. There are few people which are having the lesser height. There are few people which are having the greater height. So that is why this normal distribution is very, very popular and very, very normal. Actually, this is so normal that we call it normal distribution. Now you can guess it, like how normal it is to get this normal distribution. And with respect to gate, I think they have not asked any question. I think they have just asked one question, I think, till now. Actually, in the whole continuous, they have just asked 2-3 questions, I think. I'm not 100% sure, but maybe like 4 questions they have asked. So with respect to gate, it is not important, honestly. I mean, with respect to gate, you are just good with the 2-3 things. That minus infinity to infinity fx is just 1. You should be good with this. And another thing is, at max they can ask you about the uniform distribution. That is all. I mean, with respect to gate, this normal and exponential distributions are not important, but in the machine learning or in general life, this is important. Okay. So, but anyway, for the sake of completion, we have to study this distribution also. Otherwise, they have not asked any question from this distribution. I think they have asked just one question. I may be wrong. Maybe there are 2 questions, but I think they have asked just one question. Okay. So anyway. this distribution is symmetric about the mean, which means like we need to calculate the mean obviously, but let's suppose I calculate the mean, I calculate the expected value, then expected value will come out to be in between only. This is the expected value. This is symmetric about the mean. Okay. And the PDF is having this formula. See, in case of uniform, what was the formula of PDF? Do you remember? It was 1 upon B minus A. Okay. In case of uniform, here it is having some formula which is looking like this. I mean, which is 1 upon under root 2 pi sigma or maybe something like this. Let's not worry about this formula at all. I mean, for the gate purpose, this formula is not important. So I will not ask you to remember this formula also. Okay. I mean, you do not need to remember this formula. But yeah, there is some formula of PDF. And if you plot this with respect to x and fx, this mu and sigma are just parameter. I mean, you can just treat them just some constants, maybe k1, k2, something like this, which means maybe you can say this is, let's suppose this is some constant, this is k1, this is k1, this is k2, something like this, which means if they give you k1 and k2, if they give you these two parameters, then you should be able to find out this fx. Okay. Similarly, what are the parameters in the uniform? Can anyone tell me what are the parameters in uniform distribution? Parameters means anything apart from x or k. So A and B are parameters. Okay. So we generally call it uniform bracket A comma B. So in the bracket, we generally write the parameters. I mean, that's a general notation. So A and B are the parameters means if they tell you A and B, can you plot the uniform distribution? Can you plot the PDF? Can you find the probability? Then we can do everything. If they give you A and B, so that is why A and B are the parameters. So here the parameters are K1 and K2. Okay. I mean, they will give you two numbers and then they will ask you few things. They will say based on these two numbers, let's have some normal distribution. Okay. So for the gate purpose, actually this formula is not important, but that's okay. I mean, we are just having this in the slide. Now, if you calculate the expectation using this formula, then what is the expectation? This is minus infinity to infinity x fx. Okay. If you put that fx, that complicated formula, that is basically, I do not even remember, but yeah, this is 1 upon under root 2 pi sigma into e power minus x minus mu square by 2 sigma square, sorry. Okay, so this is fx. If you put it, then you are going to get some value, and obviously that will be in terms of this k1 and k2. I mean, the x will get eliminated. That's okay, right? I mean, you are integrating from minus infinity to infinity. You will not be having any x term. Obviously, you will be having any term which are either mu, sigma, 2, or some constant, right? So finally, like if you do it, we do not need to do it, but finally the answer is mu. Okay. Obviously, we never need to do it, but the finally answer is mu. So basically, the expectation is mu. And similarly, if you find the variance, I mean, first you find the expectation of x square, and then you find the variance, which is basically expectation of x square minus expectation of x. Then it is coming out to be sigma square. Okay, I mean this term square, whatever is this term. So anyway, they will not ask you the formula. They will not say these kind of things. They might say that, okay, expectation and variance. They might give you expectation and variance, which means they have given you K1 and K2. I mean, this K1 and K2 they have given you, right? They just need to give it K1 and K2, which means they give you K1 and K2, and they can ask you anything about this PDF or these things. I mean, in general, right? I mean, you should be able to get from this formula, you should be able to plot and everything. What are the required things here? K1 and K2. What are the required things here in case of uniform? What are the required things? A and B, right? And distribution. What are the required things in Bernoulli? What are the required things? It is N and K, right? If you ask about the Bernoulli, the formula is N and P. N and P. Not K. I mean, the K will be given, x equal to K. This is the value of x. A value of x is not needed. And then they will say p power k into 1 minus p power n minus k, something like this. These are called actually parameters. And generally people write like this: Bernoulli bracket mein parameters, uniform bracket mein parameters. Similarly, normal distribution, instead of writing whole normal, generally people write like this: normal distribution bracket mein parameters. Okay, k1, k2. Something like this. I mean, this k1 is actually just mu and k2 is just sigma. So they will write mu sigma. So basically, they will give you K1 and K2 mu sigma or something like this. Then they can ask you anything about this normal distribution. I hope that is fine. Okay. Okay. Now, instead of giving you K1 and K2, they will say the expectation variance. I mean, they will be just bit clever. They will not say that mu and sigma is this. They will say expectation variance. Then, can you map, like, see, one thing is that they will say that mu is this and mu is 3 and sigma is 5. Let's suppose they say this. Then, obviously, you can draw all the things, you can do all the things. That is okay. But instead of saying mu and sigma, they will just say expectation and variance. Since I know that expectation is same as mu and variance is basically sigma square, so I should be able to calculate mu and sigma given the expectation and variance. Okay, so they will not say directly mu and sigma. Like they could have said it because these are actually same, but instead of saying like this, the mu is this, sigma is this, they will say expectation is this and variance is this. Okay, so you just need to calculate mu and sigma using the expectation variance. That you can easily do because this is just same. I mean this is sigma square, but that is okay. तो इतना समझ में आया, right? So basically this is very general phenomena, and how they will ask you question I will tell you, but they will not ask you question related to the formula of this fx. Okay, the formula is complicated, they will not ask you. I will tell you that how they will ask you. Before that, let's have some interpretation of this this normal distribution. Okay, so suppose let's suppose that this is the graph that I have for the normal distribution. Let me just copy this. This is the PDF, right? That's what we call PDF. Now, let's suppose that the mean here is 5 and standard deviation just tell you, I mean, the standard deviation or the variance, let's suppose anything, maybe 10. Okay, then this is the plot you are getting where the variance sigma square is 10 and mean is, or maybe let's suppose the standard deviation is 10 or mean is 5. Or maybe let's suppose standard deviation is 1, maybe 2, standard deviation is 2 and mean is 5. Then let's suppose this is one of the plot I'm getting. And now if I just say that what will be the plot if I just change the values, giving this plot, if I just change the values and if I say that what will be the plot for mean 3, then you will say the plot will be exactly same. I mean, plot will be exactly same. It might shift left and right. That's all. Plot will be exactly same, which means this width and these things exactly same because you are not changing the variance. Variance is same means the data distribution is same. You are just changing the mean. So here it is 5, here it is 3. Okay. But suppose you change the variance also, which means now if they ask you that how the plot will look like if the variance is maybe, and just a second. Let's suppose that they will ask you that how the plot will look like if the variance is something else. Suppose that mean is 5 and variance is, let's suppose, 4. Then the plot will be same or it will be different? Tell me. It will be different, right? Mean is 5. Here also see, just compare this diagram and this diagram. Mean is 5 both the places, but variance or the standard deviation is 2, but the standard deviation here is 4. So it means the variance is more. If the variance is more, then plot will be wider actually. Will be mean is 5, so that's okay. The plot will be something like this. If the variance is getting increased, okay, it will be different actually. Okay. So let's see for different, probably for some different values. Let's suppose the variance here is 1, then it will look like this. And mean is in these two cases, mean is 5 only, but variance, if I'm increasing the variance from 1 to 4, then it will be wider. Okay, because the variance, the data is varying much now. See, if you have the data, then data is concentrated here. I mean, for this plot, the data is concentrated here. But if you are having higher variance, then data will not be that much concentrated. The data will be in this range. Okay, and here the variance is 1 and the mean is 15, which means the variance is same as this. So the plot will not change. It will just shift. Anyway, this kind of graphical understanding, I just wanted to make sure that you get it. Otherwise, that's fine. I mean, you should be able to have some picture in your mind if you are understanding this particular random variable, because it's all about the how you can visualize this plot in your mind. Okay. Now, for the normal distribution, it is always symmetric. मतलब ऐसा नहीं है कि I give you any bell curve. This is called bell curve actually. Okay, these kind of curves are called bell curve. So suppose if I give you any bell curve, maybe something like this, is this a normal distribution? No. Okay, normal distributions are like this only, like this only. It may change from the variance and may change from the mean, which means it is symmetric on the mean and these kind of things. It is not like any bell curve, anything is normal distribution. No, it is not a normal distribution. It is not a normal distribution. It is a normal distribution. Okay. So if I just ask you whether this is a normal distribution, then what you will say? No, this is false, right? Following is a normal distribution and this is false. नॉर्मल डिस्ट्रीब्यूशन इज सिमेट्रिक अबाउट द मीन. इट्स नॉट लाइक कि कोई भी कर्व दे देंगे वो नॉर्मल डिस्ट्रीब्यूशन है, ऐसा नहीं है. ठीक है, नॉट ऑल द बेल कर्व्स आर नॉर्मल डिस्ट्रीब्यूशन. ठीक है. Now let's see some interesting fact about this normal distribution. I mean, like these are actually important. That's why I'm telling you. Otherwise, I could have not told you. But yeah, these are actually very important facts. I mean, I'm not sure they might ask you in the gate, but in general, it is important. You might have studied this in your 12th class. At that time, you might not be much aware, but let me just reiterate those facts. So this fact says that suppose you find out the area in between mu minus sigma and mu plus sigma. See, the complete area, you know that minus infinity to infinity, this fx, the complete area is 1, right? That's what you know. Now suppose instead of this this fx, if I put whatever is this formula, do you remember the formula? 1 upon 2 pi sigma square root of sigma. I mean, you do not need to remember, but anyway, x minus mu whole square upon 2 sigma square, something like this, right? So suppose you integrate this from minus infinity to infinity, then you are getting it 1. Okay, but instead of that, suppose you integrate this from, let's suppose you integrate this from mu minus sigma to let's suppose mu plus sigma. Okay, if I put the x, I mean, if I integrate, put the x value mu minus sigma, put these limits mu minus sigma, mu plus sigma, you do not need to do it, but I'm just telling you directly. It will be obviously lesser than 1, but the answer is 0.68. Okay, which means if you integrate from mu minus sigma to mu plus sigma, then this area is 0.68. This area is 0.68. Is this okay to everyone? So this area is 0.68, which means what does this mean? That in this interval, the probability of this interval is basically 68%. Matlab ki 68% people are in this interval only. Okay, this is very important fact. Matlab mean se this is called one standard deviation away. Okay, one standard deviation away. Mean से one standard deviation away, 68% of the population is just one standard deviation away. मतलब एवरेज से थोड़ा कम थोड़ा ज्यादा 68% people are there, जो कि एवरेज से थोड़े से कम है थोड़े से ज्यादा है. And if you talk about the two standard deviations away, which means if you just integrate this from minus mu minus 2 sigma to mu plus 2 sigma, if you calculate this fx, then it is coming out to be 0.95. Which means average से अगर आप थोड़ा सा भी दूर जाओगे ना, मतलब most of the people are in this range. 95% people, this is very interesting fact, कि 95% of people are in this range. मतलब एवरेज से थोड़ा सा, मतलब वन स्टैंडर्ड डेविएशन 68% people, टू स्टैंडर्ड डेविएशंस 95% people are in just two standard deviations. मतलब most of the people are just average. I mean, they are little lesser, which means 2 sigma lesser, 2 sigma greater, I can say, but most of the people are just average. It is very important fact and very interesting also. But if you go little more far, which is mu plus 3 sigma and mu minus 3 sigma, then it is 99.7% people. 99.7% people are just 3 standard deviation away. So if I say that, let's suppose that if I say that our the economy distribution or the wealth distribution is following the normal distribution, then you can say, suppose if I say that our Indian economy is following the normal distribution, then you can say ki Ambani, like you can say Ambani will be here. I mean, Ambani will be here. That's okay. Ambani, Adani, these people will be here. But most of the people are having just average income And if you ask me, maybe 95% of people, I can say they are having little lesser than average, and some people are little lesser than average, some people are little greater than average. And then if you ask me I mean, that depends on the obviously sigma value. I should not say little. I mean, if sigma could also be larger, but that's okay. I mean, for just sake of example, I'm just saying it little. But if you just go 3 standard deviation away, then almost all the people are in this range. सारे के सारे लोग इसी में आ जाते हैं. Isn't it interesting? ठीक है. Okay, so I think there is no power, and my battery, laptop battery is also low, so I'm not sure if power will come or not. Let's just see if we can continue. Okay, so you understood about the normal distribution, that what is happening. So basically, there is a formula. There is some formula, complicated formula. You do not need to know the complicated formula. There are few things that you do not need to know. Till now, you can say that you have not even you have not even got the flavor that how to solve the questions of normal distribution, because I have not told it. Okay, I'm just telling some facts about the normal distribution because that is important. Okay, so there is something called standard normal distribution. See, in the normal distribution, your mu and sigma could be anything. Mu could be 5, sigma could be 1, like this, right? Now, in the standard normal distribution, they said that if mu is 0, and sigma is 1, then this kind of normal distribution is basically some special to me, and I will call it standard normal distribution. That is all. Okay. So I will say that there's like generally we denote it by Z. We will say, I mean, generally we denote any random variable by X, Y, like this, right? X, Y, like this. So I will say that this random variable, okay, you can call it X also, but I will say this random variable is denoted by Z. If it is following a standard normal distribution, generally I say Z. I mean, you can say X, but that's okay. Okay. I mean, generally we say Z. So basically a normal distribution which is special, a standard means mu is 0 and sigma is 1. If that is the case and it is a normal distribution, then I will say that it is a standard normal distribution. That is all. Okay. So let's see this question, and then we will come back to the relationship between the standard and normal distribution. Suppose Z is a standard normal random variable, which means, I mean, they should not give you, but I mean, they have just given you, but they need not to give you that mean is 0 and variance is 1. So let Z is a standard normal random variable, then from here you should be able to infer that mean is 0 and variance is 1. So they are saying that Z is having some expectation at 0 and variance of Z is 1. Now find out the mean and variance of this X. If X is some new random variable, can you find out the expectation of X? Where mu and sigma are just some constant. You can say 2, 5, something like this. So expectation of X will be sigma into, since sigma is constant, expectation of Z plus mu, which is, this is 0, so it is mu only. Right? And variance of X will be, yes, Akash. So variance of X will be, this constant will not matter. So sigma square into variance of Z. So variance of Z is 1, so it is just sigma square. Okay. So that's how you can find out the expectation variance. Not a big deal. I mean, if you remember, I have just given you one example where I said this was 2, 5. I mean, there was one slide. Do you remember? Let me just show you. See. Yeah. So I have given you this example where I said the mean is 0, variance is 1. Okay. And then if X is this, then can you find out the expectation variance? This is the same. Like instead of 5, I'm just saying K1, K2. Okay. I'm just saying K1, K2. Instead of 5 and 2, I'm just saying K1, K2. That is all. That is the only difference I made in that example. So basically, given a X, given a Z, you can find out the X, something like this, right? I mean, if you want to find out the X which is having, so if I say that can you give me an X which is having expectation mu and variance sigma square, then you can say that X will be something like this, sigma Z plus mu. Okay. Now let's see another question where I'm giving you X. I'm saying that there is a random variable X and which is having mean as K1 or maybe mu and variance as sigma square. Then can you find out the mean and variance of this Z? Can you find out the mean of Z? Can anyone tell me quickly? It will be expectation of x minus mu. Since mu is constant, that's why I'm taking outside. I mean, expectation of mu is just mu, okay, because mu is constant. And upon sigma, expectation of x is given out to mu, so it is 0. Now, similarly, variance of Z will be variance of x upon sigma square, because constant does not matter in the variance. So it will be variance of x is given to be sigma square upon sigma square, it is 1. So now you have the expectation variance. So basically this is important actually, which means if they give you some random variable x, which is having expectation of x something and variance of x something. Let's suppose expectation of x is given to be mu, variance of x is given to be sigma square. And then if they ask you that what is a random variable z that you can define such that, just tell me a random variable z such that the expectation of z is 0 and variance of z is 1. Then you will say that yes, I can do it easily. You can just define this z in terms of x. Can you do it? Can anyone tell me what should be the answer? Z equal to x minus mu upon sigma, right? X minus mu upon sigma. Just check it. Just verify it. Let me verify it. Verify the expectation of z and variance of z. It should come out to be 0 and 1. So basically, this is the common case that we will be having. Okay, why we will be having? I will tell you. So basically, they will give you that the x, and they will say that convert that to a z, something like this. That's the only question possible in this normal distribution. Very, very easy, extremely easy. Which means they will give you x, they will ask you can you convert that to a z? Then you will say, yeah, let me just do it very quickly. That's the only question possible in the normal distribution. Okay, so I hope that is fine. So basically, why we are converting to z? Let's answer this question. Why we are converting to z? Which means why we are converting from x to z, where x is a normal distribution and z is standard normal distribution. Which means expectation of z is 0, variance of z is 1. Here expectation of x is mu and variance of x is sigma square. Why we are doing it? I mean, why we at all need to convert from x to z? Let's just answer this. Actually, the answer is very simple. Basically, what happens, let's suppose if you do not convert, okay, and suppose they ask you the probability that x being maybe x being less than 10, then how you will calculate? You will calculate from minus infinity to 10 fx dx, right? And then what you will do, you will put that minus infinity to 10, you will put the formula. Let's suppose the mean and variance are something like this. Let's suppose mean is 3, variance is 4, okay, variance is 4, something like this. Then the formula was, do you remember the formula? 1 upon square root of 2 pi sigma into e power minus x minus mu whole square upon 2 sigma square, something like this, I think, right? So you will put the sigma square is 4, you will put the values of mu and sigma is 2, you will put 2 here, you will put mu here, which is 3, something like this, and then you will calculate. Okay, I mean, for different mu and sigma, the answer will be different, obviously. So this is one way. But what they have done, they have calculated for mu equal to 0 and mu and variance equal to 1, which means they pre-calculated some values. Which means if I say, then they have actually calculated the values which are from minus which are, let's suppose for any value, let's suppose z is less than 10, then it will be minus infinity to 10, whatever it is, right? What is the formula? Square root of 2 pi sigma into e power minus x minus mu square 2 sigma square. So actually for z, it will be fixed. This is fixed is 1. This is fixed to be 0. Okay? For z, it is fixed. Now what they did, they have calculated these values from any interval to any interval. Okay, they have pre-calculated in one big table. Okay, there is one big table. Okay, in this one big table, they have calculated for every interval, for this z at least. If you find out, if you want to find out for minus infinity to 10, you do not need to integrate, because people have done it for you. For z, people have done. You are getting my point? For z, there is a table. For z, there is a table, and if you want to find out what is the z less than 10, which means from minus infinity to 10, so there will be some value in this table that will tell you minus infinity to 10. If you want to find out z from, let's suppose, from 5 to 10, they have calculated these integrations already, because mu and sigma were known to everyone. So there is one big table. In this table, that is table only for z. In this table, they have calculated every possible interval for z. Now, if they ask you the question about x, then what I will do, instead of calculating these complicated integrals, I will convert this x to z, and then I will use the table. So basically, why we are doing it? Because I will convert this x to z, because there is table available for z. Okay, and we do not need to, and we can directly use the table. Let's just see that how we are going to use. Okay, let's just see some example. Let's suppose that they say that z is a standard normal derivation, and then let's suppose they give you this. Okay, they will give you about the z. They will give you about the z. Actually, they will not give you the whole table. That's not a point. I mean, they will not give you the whole table. They will not ask you to look out the value for the table. They will give you the required entries that is useful for this particular example. So that is coming out from the table. That's okay. So they have given something about the x. They have asked something about the x, and then they have given something about the z. So what I will do, that x is having mean 10 and variance 4, that I will convert that to z. Can you convert that to z? What should be your z? Z will be x minus mu, which is 10, upon sigma. What is sigma? What is the value of sigma here? 4 or 2? Just 2. So this is your z. Okay. I mean, first I will convert to z. Now what they've asked that x is less than equal to 13. So let me just do it. They have asked this value. So what I will do, I will actually use this transformation. I will say that, suppose this is your z. So they want to find out x less than equal to 13. I will say, let's just subtract 10 from left hand side and right hand side. So instead of find out x less than equal to 13, I will find out probability of x less than equal to x minus 10 and 13 minus 10. Okay, which means x minus 10, I will find out this probability. Okay, probability of x minus 10 less than equal to 3. And instead of this probability, I will find out the probability of, I will divide by 2. So I will say this is same as probability of x minus 10 by 2 less than equal to 1.5, right? 1.5, 3 by 2. So basically what I will do, instead of finding out for x, I will subtract by 10, I will divide by 2, and then I will say that this is same as z. So this is probability of z. Since this is same as z, z less than equal to 1.5. And then they will give you something about the z. They have given you this, which means this is 1 minus z greater than 1.5, which is 0.0668. And that's how you can solve this question. So that's the only type of question that are possible in normal distribution. So basically they will give you something about the z, and then they will ask you something about the x. What do you need to do? You need to convert that x to z, okay, step by step, and then you can get your answer. Okay, that's the only thing that they will ask. Let's just solve this question. Z is a standard normal random variable, and we know that z is less than or equal to 2.4. So they've asked this. Okay, so can you convert that to a z? What is z? Z is x minus 100 upon variance is 15. Okay, variance is 15, which means it will be square root of, should be variance, or let's suppose this is standard deviation. Okay, I mean, for the sake of example, let's suppose this is standard deviation. Okay, let's assume that to standard deviation, then it means divided by 15. So what you need to do, probability of, first you will subtract 100, right? You will subtract 100 greater than 36, and then what you will do, you will divide by 15. You will divide by 15, then x minus 100 by 15 is greater than 36 by 15, which is I think 2.4. Okay. Now you will say it is Z. It is Z, which means probability of Z greater than 2.4. And then have they given you some hint about the Z? Yes. What is that hint? They have said like this. So it will be 1 minus 0.9. That's how you can calculate. That's the only question possible, which means they will give you something about the Z. They will ask you X. The whole story is boiling down to these things only. Z is also a normal distributed random variable, but it is just a special, which means the mean and variance are fixed. Let's see this. Okay. So the average height of the certain age group of the people is 53, which means mu average is given to be 53. The standard deviation, which means sigma, is given to be 4. If the variable is normally distributed, find the probability that a selected individual will be less than 57 inch, which means probability of x less than 57. So let's just convert that to a z. Z will be x minus 53 by 4. Okay. So which means it is x minus 53 by 4 less than this will be 1, right? So it will be z, the probability of z less than 1. Let's suppose, okay, they will give you in the question, don't worry. Let's suppose that they give you probability of z less than or equal to 1, 0.8413. Let's suppose they give you this. Then what is the answer? C, right? Yes, C is the answer. Very easy question. Like what you need to do, you just need to convert that to a z and then finally see that what they have given about the z. Okay. Okay. So tell me whether it is true or false. See, if z is standard normal distribution, okay, this is standard. Standard means it is symmetric about the basically. I mean, all the normal distributions are symmetric about the mean, but if it is standard, it will be symmetric about the 0. So they are asking z less than or equal to minus 8. This is minus 8. This is plus 8. Since it is symmetric, so this area and this area is actually same. So this is true. Okay. I mean, you can prove it mathematically also, but let's not do it. I mean, using the graph, we should be able to convince ourselves. So these are the small things that are needed. I mean, they will ask you just this kind of question at max. I don't know like whether they have asked any question till now. Maybe I think they have asked just one question in this normal distribution, but that's okay. Let's just solve this distribution, this question. So X is a normally distributed random variable. I mean, this is mu and sigma. Okay. So mu and sigma square. So basically, mu is given to be 70, let's suppose, and sigma square. I mean, these are the notation. If you are not comfortable, let's not worry about it. I'm just telling you this mu and sigma square. Sigma square is given to be 10 square. A normal random variable, mu and sigma are given. Okay. Find Q such that this. You need to find Q such that this, which means that P is mod of x minus 70 is greater than or equal to Q is equal to 0.32. You need to find this. Can you do it? Do you know x greater than or equal to 5? Mod x greater than or equal to 5, it means what? What are the possible values of x? X could be greater than 5 or x could be less than minus 5 also, right? Less than or equal to, greater than or equal to. Because this is mod, if it is less than or equal to minus 5, which means minus 7 or something, then also it is true. So basically, you can say it is greater than or equal to 5 and less than or equal to minus 5. Right? So this probability, just 1 second, it should be the summation of this, right? Probability that this x minus 70 is greater than or equal to 9 plus probability that x minus 70 is less than or equal to minus 9. Minus q, sorry, it is not 9, it is q. Okay. Now let's just convert that to a standard random variable. So standard random variable, if you convert, how it will look like x minus mu upon sigma. X minus 70 upon 10. If you divide by 10 in both the cases, here, then it will look like this. So it is z. So finally it is coming out to be probability of z greater than or equal to q by 10 plus probability of z less than or equal to minus q by 10. ये समझ में आ रहा है? See, probability of z greater than or equal to q by 10 plus probability of z less than or equal to minus q by 10. ठीक है? which means they have given you something like this. They have given you this. I just opened this up and then I said it is plus, and then I converted that to Z. Now tell me, Z greater than equal to some value and less than equal to some value minus of that value, isn't it same using this observation? Less than equal to minus A and greater than equal to A, isn't it same? Since it is same, I will say that that is given to be, it is 0.32. So it is given to be 0.32. You will say this is 2 into P of Z greater than equal to Q by 10 is equal to 0.32. Which means P Z greater than equal to Q by 10 is 0.16. And now let's just see if they have given something. They have given this. If they have given this, then can you tell me this is what? Greater than equal to. Can you convert that to greater than equal to? Probability of Z greater than equal to 1 will be what? 0.16. I mean 1 minus this, right? So they have given Z greater than equal to 1 is 0.16, and I came out to be this. Then can you just compare what should be the value of Q? If you compare these two, the value of Q will be Q by 10 will be 1, and the value of Q will be Q equal to 10. Okay. See, everything will just boil down to one thing, which is you need to convert X to Z, and you should be able to solve all the questions. This is the, you can say one good question where we are using like this trick also. I mean, this as a trick. Okay. And that's the enough tool that you need to do or you need to have to solve any gate question or in future if they ask. Okay. Yeah, Q is 10. Final answer is 10. Okay. So it is very easy. I mean, they have just asked one question from this probability distribution. If you want, just try this question as a homework. And this is very, very good question. Just try this question as a homework and you will like this question. They've just asked one question, and that one question itself, they've asked very good question. Okay. Try this question as a homework and we will meet in the next question. So we are just left with exponential distribution, and then okay, as a homework also, don't do for the exponential, at least do for everything else. For Bernoulli binomial position and uniform, in case of uniform, both the uniform. Just write all these values. Okay. Expectation variance, PDF or PMF. As a homework, just fill this table. I mean, you can fill this table using your notes. That's not a problem. I just want to have one table in front of you as a summary. Okay. You should be having a summarized table. What is the expectation? What is the variance? What is the PDF or PMF? You can just do it as a homework. So just do these two things, which is this, and another one is this. Yeah, Akash is saying probability now seems nice. Actually, to be very honest, probability is tough. Okay, I mean tough in the sense it is not intuitive. Just like linear algebra, probability is not intuitive. Linear algebra is very intuitive, but probability is not intuitive. But anyway, like you might have got much idea about the probability. But after this also, after this mean, mode and median, you will get to know, you will get to understand more probably, because here I will be using some intuitive ideas in the probability. Okay. So we will meet in the next class at 7 a.m. only.